This video is about basic vector applications, like how do we use vectors in real life, and how do you solve those problems? Let's see. Okay, so these are the steps that you're going to follow anytime you have a word problem that involves two vectors and you want to find the resultant vector, like how does one vector affect the other. So here's what you're going to do. First, you're going to draw separate pictures for each of the vectors, label the angle, and label the magnitude of each. Second, convert any bearing angles that are given to vector angles. Calculate the component form of each of the vectors. Remember, that's with the cosine and sine stuff. Let's just mark that. Remember this equation we just used? Add the component form, so you're just adding the two results you got. Calculate the magnitude. Remember, to find magnitude, it's just the square root of v1 plus v2, each of them squared. Calculate the angle of direction. Remember, that's inverse tangent, using the resultant. So after you calculate the angle of direction, using the resultant vector, you're going to look and see what quadrant. Is it northwest, northeast, southeast, southwest? And then you're going to make sure you're going to report your answer in units. Okay, magnitude could be miles per hour, feet per second, things like that. And then the angle, the course, is like northwest, southeast, things like that. So I'll show you as we do a problem here. Okay, number one, a whitewater raft that you're traveling in is speed of 35 miles an hour, heading northwest at 35 degrees. Okay, so I'm going to draw this out. Northwest is this direction. Remember, 35 degrees is this right here. Okay, now in order to know what that vector angle is, I just need to add 90 degrees to it. So I get 125 degrees. Okay, and the speed is 35 miles per hour. So I can find my component form of the vector. Remember, we do the magnitude times the cosine of the angle times the sine of the angle. All right, let's crank this out. 35 cosine of 125. This gives me negative 20.1. And this gives me 28.7. Okay, so that's my vector 1. That's the vector of the raft. Okay. Now, to move ahead, I need to find the vector for the current of water. It's going southeast, so it's 51 degrees here. So I need to know the angle from 0. Well, if this axis is 270, I'm just going to add 51, which is going to give me 321 degrees. Okay, the speed was 20 miles per hour. So to find this vector, I'm going to do 20 times the cosine of 321 times the sine of 321. Let's crank this out. $15.5 and negative 12.6. All right, so that's vector 2. Now to get my resultant vector, I'm just going to write vector 2 under this one. And then I'll have to just add these up. That's all I do. So I'm going to put an R for resultant vector. I get negative 4.6. And 16.1. All right, that's my resultant vector. Now I need to do the magnitude of this resultant. So remember, take the square root, and then we square the horizontal component and add it to the square of the vertical component. Make sure you take the square root, and when I do that, I get 15.4. And this is miles per hour. Okay? So look at that. Your original raft speed was 35 miles an hour. The current's 20 miles an hour. So it's slowing you down quite a bit. Okay? So this is my resultant magnitude. Now I need to find the angle. So I draw myself a quadrant, and then I look back at my resultants. Look, x is negative, or my horizontal, is negative. My vertical is positive. That means it's over here in quadrant 2. And this is 16.1. So to find my angle, I have to do the inverse tangent of y over the x and when I do that, I find out the angle is negative 74.1 degrees. Remember, we throw the negative out, so ignore that. 74.1 is this angle right here. Remember, with bearing angles, I have to measure the angle from the vertical, from the north-south line. So in order to get that angle, I really just have to take 90 minus 74.1. And I get 15.9. Okay, so the way I report my answer is 15.9 degrees. And what direction is this? Well, this is northwest. Okay? So it's changing my direction quite a bit. Originally it was 35 degrees west, but it's getting shifted down quite a bit because of that southeast current. Right? Don't get overwhelmed, just take it in baby steps. Another one. A jet is flying at a speed of 450 miles per hour heading south 57 west. There's a strong wind blowing 50 miles an hour towards the northeast. What's the resultant magnitude and direction of this flight? Okay, so let's do the jet first. All right, my jet is going southwest, so it's coming down here, 57 degrees, okay? I need to figure out what is this angle from the 0 mark, the true vector angle. Well, I know that this axis right here is 270, so I'm going to take 270 and I'm going to subtract 57. And when I do that, I'm going to get 213 degrees. So that's my angle that I'm working with here, okay? 213 degrees, and it has a magnitude of 450. So if I do my component, to find my component vector, I'm going to do 450 times the cosine of 213 times the sine of 213. Okay, give me this. I get negative 377.4 and negative 245.1. Okay, so that's that vector. Then I'm going to do the wind. Okay, I'm going to label this the wind. The wind is going northeast, okay, at 51 degrees. Well, if this is 51, what's this angle? That's basically 90 minus 51, which is just 39 degrees. Okay, so to find this vector, I'm sorry, this would be vector 2. The magnitude, the speed of the wind is 50 times the cosine of 39, the sine of 39. Okay, calculate this out. You get 38.9 and 31.5. Okay, so that's vector 2. So to get my resultant vector, I'm going to add these guys. To 18.6. So this is my resultant. Okay. Sorry. All right. To 13.6. Okay, so there's my resultant vector. Now do magnitude next. Square root of this squared plus, thank God for calculators, it will do this for you. It's my 400.3 miles per hour. That's my resultant magnitude. Okay, partially there. Now I need to find the direction now that that's going to change the direction of my jet. So look at your values. They're both negative. The horizontal and the vertical are negative. That means you're down in quadrant 3. right? So if the horizontal is negative 338, or 0.5, sorry, and the vertical is negative 213.6, here's my theta. So I need to do the inverse tangent of negative 213.6 over negative 338.5. That'll tell me what that angle is, right? So that gives me the angle of 32 degrees. Now, that angle of 32 degrees is the angle between here and the x-axis. I need the angle between the y-axis and that. So all I really need to do is then take 90 minus that 32. It's 32.3, sorry. 32.3, and that'll give me my correct angle. So my real angle is 57.7 degrees, and it's going to go in the southwest direction, okay? Southwest direction. So you'll notice that the angle, that the resultant angle is not all that different than what it was to begin with. However, the speed is changed. It was flowing 450 miles an hour, but this wind is slowing it down to 400 miles an hour. So that's what resultant vectors do.